Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The stability of the enol form of a carbonyl compound depends on whether enolization leads to a product that is stabilized, example, by aromaticity, conjugation, intramolecular hydrogen bonding, or destabilized, example, by loss of conjugation, ring strain, anti-aromaticity. Moving on to the next step. Analyze option A, cyclobutane 1,2,3 trione. This compound has 3 carbonyl groups on a 4-membered ring. Its enol form would be stabilized by extensive conjugation and possibly by aromaticity like delocalization. Squaric acid derivatives are known to have stable enol-enolate forms due to aromatic stabilization of the dianion. The enol form is relatively stable. Moving on to the next step. Analyze option B, cyclopentane 1,2 dione. 1,2 diatones in a 5-membered ring readily enolize, and the resulting enol is stabilized by intramolecular hydrogen bonding between the enol and the adjacent carbonyl. This makes the enol form quite stable. And for the final step, analyze option C. The structure shown is a cyclobutane with an exocyclic or endocyclic double bond adjacent to the carbonyl, a 4-membered ring with 1C is equal to C and 1C is equal to O, resembling cyclobutane. For the enol form to form, a proton alpha to the carbonyl must be removed and an OH placed on the carbonyl carbon. However, the resulting enol would place a double bond in a 4-membered ring in a way that creates a cross-conjugated or anti-aromatic system. A 4-membered ring with 2 double bonds, cyclobutadiene-like system, is anti-aromatic, 4 pi electrons, making the enol form highly unstable. Therefore, the enol form of this compound is unstable. Analyze option D, 2-cyclohexane 1-1 cyclohexane. This is an alpha-beta unsaturated ketone. Its enol form would involve the dienol, which can be stabilized by extended conjugation. The enol form is reasonably stable due to conjugation. Conclusion. Option C has an unstable enol form because enolization of the cyclobutane would generate a cyclobutadiene-like anti-aromatic intermediate product with 4 pi electrons in a 4-membered ring, making it energetically highly unfavorable. The other options all have enol forms stabilized by aromaticity, conjugation, or intramolecular hydrogen bonding. Therefore, the correct answer is C. Therefore, the correct answer is option C.